Right, so this is something that will only make sense to most biomechanists, but let me just explain what's happening, okay? This is a lesson in sometimes you really have to write out the math by yourself instead of relying on generations from AI, right? So let's start with the story. The goal of this project, again, apologies for my screen, is to quantify the motions at the shoulder joint for baseball pitching, but I'm doing it from scratch. Instead of using like a pre-built software like Visual 3D, which I do have access to, but I am actually really rough on it. So the foundational concept here is that when we are trying to quantify a 3D joint angle between two body segments, one method is to use what's called the Cardan-Euler angles, okay? So basically what this does is like they consider 3 consecutive rotations of alpha, beta, and gamma to quantify, basically how segments move relative to each other. It's a very standard way. It's not just coming from biomechanics, but it's a very standard way of quantifying relative orientation of body segments. And one thing is, this is simply a product of multiple rotation matrices. Again, if this is falling over your head, don't worry about it. Multiple rotation matrices that's multiplied together. And you can see like the trigonometry gets kind of intense, but eventually the calculations are fairly simple where you can obtain this R rotation matrix for multiple pathways and just comparing that against this trigonometry / algebra, and you're able to calculate each of your angles. And these are your anatomical angles, for example, flexion, extension, valgus, and then rotation angles. And that's how you pretty much do it in principle. And you know me, I wanted to use some of our most advanced AI tools, and then I just could never, I swear to God, I could never get the right angles. The signage is always the opposite for some reason. And then, I've been doing this for days. And eventually, I went and wrote out all of these matrix multiplications. And guess what? The AI forgot a minus sign.